Alright, muchachos. So we are going to move on to a new section, section 5, and we're also going to be introducing a new concept, alright? So let's just get started with problem 5. It's called countdown to image, alright? So this problem has two subproblems, problem A and problem B. So let's just get started with problem A. So notice how the countdown data definition below uses mixed types of data, namely a Boolean, alright? So the Boolean false, a set of numbers, and then the string completes, right? Finish running the template for countdown. So as you can see, the first 3 steps are filled in. We just got to do this last step, which is a function template that processes this data. All right. So hopefully this rings a bell. This is very similar to, similar sounding to enumerations. There's a one of in this. So we need to write a cond temp cd. All right. And then how many branches do we need? Well, there are 1, 2, 3 cases. So we need 3 branches. So 1, 2, and 3. All right. So very similar to enumerations. Here's the big difference. There are 2 or more types of data. So now we have to distinguish between what the types of data are and then what value it is. All right. So there are 2 questions going on here. Let's contrast this back to enumerations. All right. So enumerations, here is an enumeration of letter grades. So this is the letter grade. Is this the letter grade? That's string A, string B, string C, string D, and then the string F. There's only one type going on here, and that is the type string. All right, let's move on to another one. This is number grade. All right, this number grade enumeration only enumerates over one type, and that is of type number. All right, here we're dealing with multiple types of data. Therefore, we need a way to distinguish between those types of data. Right? So I'm going to phrase this in a way that's hopefully easy to remember. We're going to ask who you are, and then we're going to ask what you are, all right? So how do you ask who you are, all right? Since we're asking 2 questions, we need an and here. And how you ask who you are is, if you go on this website, I'll link this in the description, it's called base generic, all right? So let's say string question mark, given this x, it will produce true or false if this x is a string, right? It can be any other type. If it's a Boolean, I'll just produce false, etc. All right, I'm going to contrast these 2 types in the REPL over here. So string equal string all right? So we're given a string, we'll produce true, all right? If we're given a number, no problem, we'll just produce false, all right? Contrast this to string equal which if we pass in a number and then say, does this equal, hello? This is not going to produce a Boolean. In fact, this is going to produce a crash. All right, so this is why we have to ask who you are and then the what you are before we pass in this as a, we got to make sure that this variable over here is a of type string, all right? And this doesn't produce a crash, this produces a Boolean. And we can use that in this con branch, right? So let's ask the who you are of this first case. So I happen to know that it's called Boolean, So is this countdown that we're given of type Boolean? If it is, then we then have to ask what you are, right? And then we're going to say cd false, if I can spell that. All right, so that's the question for the first case. Let's move on to the number case. So and number, cd, and then, the intervals. So is n greater than or equal to 0, and then does n fall under 10? If so, do something. And then finally, this last case of strings. So and then string and then string equal and then write the what value are, and then complete. There we go. And that is the template done for this function, all right? Who and then what. All right, and the what is not really that important. In fact, you'll see that we're going to factor it out pretty soon, right? We really want you to get used to asking who you are when you see cases of 2 or more types of data, right? So that is problem A done, right? So now let's just move on to problem B. All right. Oh, and whoops, and this variable is not defined, so this has to be cd. All right, so now let's just run it, it should be fine. All right, so problem B. Write the function countdown arrow image that consumes a countdown and produces an image. Here are a set of examples. False should produce an empty image. Numbers should produce the image of the number. Use the text function from the image library. And then here's a string complete should produce the image of this text. All right, again, using the text from the image library. All right, so pause the video and try to work through this on your own. It's all right because I'm introducing a new concept. I don't expect you to, get this right away. All right. So anywho, I'm assuming that you guys took a good swing at it. I'm gonna go over the spoilers in 3, 2, and 1. All right. So countdown to image. First comes the signature. So it's gonna consume a countdown, because that's what the problem statement states, and produce an image. All right. So produce image version of countdown. All right, not too descriptive, but I'll come back and fix it later. Next is the stub. So define countdown arrow image, consumes a CD, and then we'll produce an empty image. So that's a special variable that comes in when you have this on the top, right? So hopefully it's not too surprising. All right. So next there, a set of examples. Check expect. Countdown arrow image. So we're going to be given false. What happens when we reduce false? We're given false. We just want to reduce an empty image. All right. So next is when we're dealing with numbers. So let me just do that. Do image, and then what happens when we're given the number 10? So we're going to use the text function from the image library. All right. And I'm going to search it up because I don't know what the parameters mean. So let's see. What? It didn't scroll me to it? All right, we'll just have to look it up ourselves, guys. There we go. So text. The first argument is a string, and then the font size, and then the color. So we want to produce this string of 10. All right, and then the font size we'll use 24 for now, and then we'll use the color red. All right. So there we go. Let's do one more example, testing the boundary cases of 0. So given 0, we should produce the string 0, and then at 24 red, all right? Let's do the last test here. So countdown arrow image of complete, complete. There we go. You want to produce a text of 24, also red, of the string right here, all right? So let's just plop this down. All right. All right. So there we go. So pause the video and really, try it out on your own, because this should be all the mental scaffolding needed to solve the problem, right? So I'm going to go over spoilers in 3, 2, and 1. All right. So first let me run the test and make sure that they all fail. Looks like there was a typo here. This should be the string red, not the variable red, because it's not defined anywhere. So there we go. Okay, good. All failing tests. So now we got to produce those cases. So next we can use the template. So since the stub ran, let's just use this template. And there we go. We're going to rename it countdown arrow image. All right, so in the first case, we want to produce, let's see, an empty image. The second case, when it's between 10 and 0, let's see, we want to use text. And since this is the changing argument here, we're going to be giving a countdown, and this can be, a number between 10 or 10 to 0. So it could be 7, 4, etc. So you have to use the number arrow text. Number arrow string, I mean. And then we'll give it the CD, all right? Which should be the number. And we want to do the 24 and then red. All right. In fact, I'm going to space this to a second on a new line, so hopefully it's easier to see. This is the question. Second line, the line beneath is the answer. All right. So question, and then the line under is the answer. So I'm going to do this over here too. All right, so let's do this last case, this last test, and we can just copy and paste this test down, because that's exactly what we need to do. It doesn't really use CD at all right? Okay, so now we run this. All 4 tests have passed. All right, good job. All right, so here are the rules for simplification. All right, we can make this function a lot simpler. I'm going to copy and paste this down to make the optimized version. All right, so I'm going to comment the first one out. There we go. All right, so when you have only one type of data each, right, there's only one Boolean in this set of data. We don't really have to ask what the what is, right? We just need to be concerned with the who. So the what really doesn't matter in this case. It only matters if we have another case here, right? True, and that meant, something else for the countdown. And this could be way down here, doesn't really matter, right? So now there are 2 Booleans here. And now you really have to ask the what you are, right? In this case, there's only, one boolean here, so we don't even have to ask the what you are, right? So this is the what you are. If I just replace this with true, right, the constant true, I'm going to delete this, so hopefully you guys aren't confused with like the two instances on the screen, right? This should pass all the tests, and so they do. Therefore, we don't need this and at all. So we only have to ask who you are. If you're of type boolean, produce the empty image, right? So likewise with all the other data types, right? There's only one set of numbers here, and that's 10 to 0. That's fine. We only need to be concerned with the who you are. So this is the who you are, and then these are the what you are. So let's just replace the what you are with the constant true, and we can see that it's going to function exactly the same. So therefore, we don't even need this and right here. We just need to ask one question, that is the who. All right. Of course, likewise with this lost case, we only need to be concerned of, who you are. So you're of type string. I don't really care if you're the string complete. So there we go. Unless there's like another string over here, like right below, or we chose, for this to be, not started, right? And then we need to ask the what you are along with the who you are, right? In this case, we just know that it is not the case here. All right, so this should produce the same behavior, just with a little less code and less checks, right? There's an additional rule in that if this is the lost case, we can just write else. All right, we don't even check if it's string, the type string here. All right, because by process of elimination, if you're not a you're not a boolean, and you're not a number, well, the only case you have to be a string. Therefore, hey, else, all right? I don't care, right? So the only thing, you are is a string, and we're just going to produce Happy New Year. And that is how you simplify a union and the template for this, all right? And likewise, you would have to revise this template and delete these checks. All right, so this is simplified, and it works. All right, so let's move on to the next problem. 5.01 is called the next light, all right? So this problem has two subproblems, all right? Very similar to the previous problem. It's going to deal with unions. So let's just start it with problem A. So notice how the traffic light data definition below uses mixed types of data, right? There's a boolean in here, and then a set of strings, right? So finish running the template for traffic light. All right, so pause the video and try to work this through your own, right? The first 3 steps are done. We're just going to write a template for this. So I'm going to go over spoilers in 3, 2, and 1. All right, so I'm going to assume that you guys took a good swing at it. So traffic light temp, and I'm going to say TL con. All right, we need 1, 2, 3, 4 cases. So 1, 2, 3, 4 cases. All right. And then we have to ask who you are and then what you are. So, so are you of type boolean? Nope, not false. TL. And then boolean equal, is asking the what you are. All right. So that's one done. Next we have to do the one for strings. So and string TL, and then we have to check if it's, equal to red. So string equal and then we're gonna say TL red, and then we're gonna do something in that case, and then keep going. So there we go. That's for yellow, and then this is for green. All right. So yellow and then green. And then just in case you missed it, false means off, and then of course these strings mean the color of the traffic light. All right. All right. So that is problem A done. All right. Let's move on to problem B. All right, so notice how steps of the design recipe has been done for next light. All right, so we can see that the signature, purpose, and stub are done. We just write the examples in the other steps. All right, finish the function. So here's the signature, here's the purpose. Red turns to green, green turns to yellow, and then yellow turns to red, and then false just stays the same. Okay, all right. So pause the video and try to work through this problem on your own. I'm gonna go with spoilers in 3, 2, and 1. All right, so we have to write the examples. We have to write the test cases here. We also gotta write the stub. So let's just do the stub first, actually. So we're gonna say next light, because it's a traffic light, we'll call it TL, and produce false. All right, next are the examples. So next light, TL, no, not TL, we're going to be given a traffic light, and that traffic light can be false because this traffic light, we have to go look up as to what they are. So false, and then the string's red, yellow, or green. So let's just do that. So given false, we have to do produce false. All right, because this is what it says. False stays the same. All right, let's just do the other cases. So red turns to green. So the string red then turns to the string green, like a real traffic light. And then what? And then green turns to yellow right over here. We'll just turn that into a test itself. So we're going to say green then turns to yellow. And then finally the last case, right? Yellow turning into red. All right. So here is yellow and then red. There we go. Okay. So now we're going to run, make sure there are no typos or anything, and they're all failing, but it's all good. Okay. All right. So now really pause the video and try to work through the solution on your own. We'll go with spoilers in 3, 2, and 1. All right. So hopefully that was all the mental scaffolding needed. We'll copy down this template and paste it in here. All right. So what happens in the case of this when we're given false? Well, we just produce false. All right. What happens if it's the string red? Well, we're going to produce the string green. And then what happens when it's yellow? Well, we're going to produce red. And then lastly, green produces yellow. All right, we're going to run this. Hopefully all the tests should pass. Oh, and I forgot to rename the function from the template. There we go. All 4 tests pass. All right, so now let's just get into simplifying this. So let me just make a copy of it and then comment the first one out. So I'm just going to comment it out like this because it's kind of distracting when you see the highlighting. So there we go. All right. So there's only one Boolean in this data definition, all right? There's only the Boolean false. And if you remember what I said a few moments ago, if there's only one type here of type Boolean, that's, false, then we can just remove the what you are case, all right? We're only concerned with the who you are in this case. Of course, just a reminder, if there were like another Boolean here and that is true, then we would have to be more concerned, all right? But in this case, we know that there's only one Boolean, and that is just false. So we don't have to really care about what you are. As long as you're Boolean, then we're just going to do that. As long as you're a Boolean, more specifically, you're only going to be false, so I don't really have to ask, the what you are, all right? So that's one case down. All right, so these strings. So what we're trying to prevent here is that we're trying to prevent this case from happening, right? When TL is false, we don't want to do this, right? Because this is going to produce an error. I'm going to run this off to the side here, right? It's going to crash the program. And that's what we're trying to prevent here. And this first line, this first con statement over here prevents that because it's going to hit this con statement first, and then it's going to produce false. So we know that this TL is never going to be false. It's never going to be a number, and etc. All right? We know that right after this Boolean, in this data definition, are just a set of strings. So now we don't even have to be concerned with the who you are in terms of asking who you are in the rest of these cases. So really we can just ask the what you are, because that's the main distinguishing factor, all right? If we didn't ask, the what you are, then this string TL, this is going to produce true for, any string. And that means that it's only going to produce green, and therefore, these 2 tests will fail, all right? So anywho, since we know that right after the Boolean is only one type, and that type is string, we're guaranteed that this TL is going to be string. Therefore, we don't really care about the who you are anymore. And if I just paste this there and run this, I already kind of renamed that to green, my bad. There we go, whoops. And run it, it should still pass all the tests, just with more simplified code, all right? And of course, we can just turn this last case into an else, all right? And then just run this again, and it's all good, all right? So just to recap, you learned about unions, you learned how to simplify them, you also learned how they compare to enumerations, and yeah. One last thing here is, you might be wondering, why are we running the template again? You might, try to simplify this before you, write the function. But again, that's not too wise. The template should be a very mechanical step. You see you see the cases here. You plop down 4, and you mechanically write the cases of who, what, right? You do this without even thinking. That's the key part. And then when you write the function, you can do some thinking and go, all right, I can simplify this. It looks like it's not concerning itself with the who or the what you are in some certain cases, etc., right? So mechanical, and then intuition after you get used to why we're doing the mechanical first. All right? Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.